This video summarizes the current management practices for nuclear waste in Canada and provides insight into future technologies for storage. The social and political obstacles surrounding implementation of these technologies will be discussed.
Canada currently operates 5 nuclear power plants in Ontario, Quebec, and New Brunswick. There are 22 CANDU reactors in operation, which use unrefined uranium pellets as fuel and heavy water as a moderator. These pellets are packaged into bundles to be used inside the reactors for power generation. When these bundles reach the end of their functional lifetime, they are removed from the reactors and classified as nuclear waste.
As of 2016, 2.6 million bundles of spent nuclear fuel were present in Canada, with 90,000 more bundles produced each year. By the end of the useful life of the reactors here, there will be 4.6 million waste bundles present. These bundles are significantly more radioactive than pure uranium, 10,000 times more so even 30 years after removal. It takes approximately 10,000 years to reach the half-life of many of the components within spent fuel, making the requirements for long-term storage a necessity.
Nuclear waste can pose severe health risks to people and the environment if not properly managed. The major concern with human health is the effects of radiation associated with cancer. In general, even short-term radiation exposure can cause damage to organs and tissues in the human body. Long-term exposure is often fatal. Studies have also shown that any exposure to dangerous levels of radiation could produce long-term health effects. These consequences, such as cancer, are sometimes not noticed until much later in the individual's life. The unintentional contamination of nuclear waste is also extremely dangerous to the environment. Radiation exposure can cause infertility in plant life and contaminate large areas through weathering. Animals are susceptible to radiation and can suffer long-term consequences depending on the exposure levels.
Currently, all spent nuclear fuel in Canada is kept on-site interim storage facilities. This involves wet storage for 7 to 10 years and dry storage until the waste is ready to be transferred to a long-term facility. When bundles are first removed from the reactor after 3 years of use, they are submerged into large pools of water to reduce their heat. Following this, they are placed into dried storage containers. In both stages of the interim storage process, the spent fuel remains shielded to reduce any risks of unintended exposure. The long-term integrity of the dry storage containers is not known, and many are nearing their originally proposed service life. Degradation effects on the internal casing of the dry storage containers can increase over time due to additional fission gas release, leading to an increase in fuel rod pressure and thus stress and strain on the casing, irradiation over time leading to cracks in the cladding microstructure, and halogenide production leading to stress and corrosion cracking. A deep geological repository is an underground storage facility that uses the Earth's geology as a natural barrier towards any exposure of nuclear waste to the environment and society. Research began on a deep geological repository in 1989, and specific design requirements for a repository have been completed by the Nuclear Waste Management Organization. Today, construction has begun on a deep geological repository in Kincardine, Ontario, adjacent to the Bruce nuclear site, which will be designed to hold low and intermediate level nuclear waste. Although there are many locations that fit the geological criteria set by the Nuclear Waste Management Organization for the Deep Geological Repository for high-level nuclear waste, a location to store Canada's 4.6 million bundles of spent nuclear fuel has not been found. This is due to societal and political impacts, or NIMBYism, that will be discussed shortly.
The world has seen disastrous cases of nuclear waste contamination and the long-term effects they have had on society. The Fukushima reactor meltdowns are a recent example, and the anxiety from these events still resides in the minds of many Canadians today. In 2008, the Nuclear Waste Management Organization published a study on the attitudes of society towards nuclear waste management practices in Canada. The study concluded that the majority of Canadians believe that the cons outweigh the pros when it comes to nuclear energy. Most Canadians do not want a repository located in close proximity to any urban locations. Additionally, the study suggests that the majority of Canadians want communities to have direct input into the siting of nuclear waste repositories, regardless of the research or scientific evidence. Another study published by the Canadian Nuclear Association in 2012 shows a continuation of this trend. In this study, only half of Canadians believe that nuclear waste is managed safely. Over half of Canadians also believe that the nuclear industry can also be described as dangerous. This trend continues today in society and poses a threat to the research, development, and funding of nuclear waste management.
There are currently several major organizations and governing bodies responsible for the policy development and regulation of nuclear waste production and disposal. Most notably, the Nuclear Waste Management Organization, the Canadian Nuclear Safety Commission, the International Atomic Energy Agency, and Natural Resources Canada. These groups work alongside the Government of Canada in implementing policies such as the Nuclear Fuel Waste Act, the Nuclear Safety and Control Act, the Packaging and Transport of Nuclear Substances Regulation, and the P290 Managing Radioactive Waste Regulation. With the protection of human health and the environment as a main concern, these regulations enforce safe disposal and transportation, mainly by shifting management responsibilities to the corporate owners of used nuclear fuel.
Pyrometallurgical processing uses electroplating to selectively remove plutonium, americium, and uranium from a bath of spent nuclear fuel. The material built up on the electrode can then be removed, cast into ingot, and converted into a fuel appropriate for use in fast nuclear reactor systems. The waste fission products that are not attracted to the electrode now have a significantly lower radioactivity and shorter half-life than in previous waste material. This is due to the removal and reuse of the transuranic components, plutonium and americium, which, with a half-life of over 10,000 years, are the largest reason behind today's nuclear waste problem. Based on this process, only 1% of nuclear fuel is wasted, versus 94% in the current system. The system, however, would need to be applied in a fast reactor system, as the uranium and plutonium recovered in this process is not as easily fissile as the uranium-235 cleaved in slow reactor systems like those used in Canada.
Seabed repositories are a method of nuclear waste disposal that is rarely discussed in modern political discourse. The objective of this method is to bury sealed nuclear waste bundles below the ocean floor. Burying the waste in repositories located far from urban locations is the major benefit of this method. However, it comes with the risk of unintended ocean contamination. While there has been research into specific procedures to use this method, there has not been enough data to back widespread implementation. International agreements also create a large obstacle for the implementation of mid-ocean repositories. Regulatory bodies and government should place a high importance on developing alternative methods to deep geological repositories.
Changes to funding and regulatory framework are required for any of the nuclear waste management options introduced in this video. Significantly more effort needs to be put into research and development of an effective storage facility that meets the needs of Canadian nuclear waste. Research has shown that long-term annual cost that will result from failing to develop a permanent solution is much greater than the investment needed to find a solution now. This investment should be funded by nuclear corporations and be implemented by a public corporation responsible for development of a disposal site. A cutoff date should also be set by the government so that selection of a disposal site cannot be deferred far into the future. This investment in long-term storage will allow for increased production of nuclear power in Canada and the protection of public safety.